All right, 4.3, writing equations of parallel and perpendicular lines. Two lines in the same plane that never intersect are called parallel lines. All right, and what they're saying there whenever they say in the same plane, we normally don't worry about saying that, but what that's saying is that they're drawn like on the same piece of paper, right? They're not, one of them is not drawn on the floor and the other drawn on the ceiling, right? If I were to draw a line on the floor and then draw a line on our ceiling, then obviously they'd never touch because they're in different planes. So whenever it says that they're drawn in the same plane, they have to be both drawn on the floor or both drawn on the ceiling. So if they never intersect, they're called parallel lines. And then two distinct non-vertical lines are parallel if and only if they have the same slope. Right? So any two lines that are parallel have the same slope. All vertical lines are parallel, and all horizontal lines are parallel. Two lines in the same plane that intersect to form right angles are perpendicular lines. Right? Perpendicular means that they meet at a right angle. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. And normally I say opposite reciprocals. They mean the same thing. Vertical lines are always perpendicular to horizontal lines. So example 5, determine which, if any, are parallel. So starting off for line A, we have to plug that in and find our slope. So I'm going to say, well, 3 minus 1 over 1 minus negative 1 is going to be 2 over 2, which is 1. Now for line B, 2 minus 4 over 0 minus 3 is negative 2 over negative 3, which is 2/3. And lastly, for line C, that's going to be 3 minus 1 over 3 minus 0 is going to be, what will that be? 2 over 3. All right, so I found my slopes. I have 1, 2/3, and 2/3. The two lines with 2/3 are going to be parallel. So line B is parallel to line C. And the way that we could write that would be line B is parallel. That's the parallel symbol. Line C. Right. For the parallel symbol, think about a ladder without the spot where you'd put your feet. Example 6 and 7. Write the equation of the lines parallel and perpendicular to the given equation that passes through the given point. All right, so let me rewrite this. This didn't work out very well. This is the point 1, 3, and y equals 2x plus 5. The other one is the point 6, 1, and y equals 3/5 x minus 5. So for example 6 first, I'll have parallel and perpendicular. And I'm going to write these equations in slope-intercept form. Right? So for parallel, the slope will be the same. So my slope is going to be 2. For perpendicular, they're going to be opposite. So in the first one, it's positive. So the second one, it's a negative. Reciprocal. So that's the upside down version. For parallel, it's 2 over 1. So this is going to be 1 over 2. Right? You flipped it upside down. Now, I want the slope-intercept form, right? I want the y equals mx plus b form here. I could do this two ways. I could put it into point-slope form and then solve, or I could plug it into slope-intercept form and then have to solve for b. I'm going to put this one into point-slope form, and then I'll solve for y. So here, I will have point-slope form will be y minus 3 equals 2 x minus 1, right? So I plugged in my slope 2, and then we said that it wants to go through this point, so I plugged that point in. Now this is point-slope form. I want to put it into slope-intercept form. That's going to be y minus 3 equals, distributing my 2 will be 2x minus 2, and then adding my 3 over will be y equals 2x plus 1. So there we are. That is the line that is parallel to the other one that goes through the point 1, 3. Now for perpendicular, I'm going to do it in the same way. I have y minus 3 equals negative 1/2 x minus 1. Solving it, I'll go ahead and distribute the negative 1/2, so I'll have y minus 3 equals negative 1/2 x plus 1/2. Adding the 3 over, I'll have y equals negative 1/2 x plus, well, it's 3 plus 1/2. Putting that in common denominators would be 6/2 and 1/2, which is 7/2. Right. And if you're uncomfortable with that fraction work there, just type it in your calculator. It works just the same. So there are the two answers for us, parallel and perpendicular. Scrolling down, we do this the same way. We have parallel. I'll use the symbols this time. I have parallel and then perpendicular. For the parallel, my slope will be 3/5, because that's the same as what is written in the problem. For my perpendicular, it will be the opposite. So in this case, it'll end up being negative. Reciprocal, so 5/3. And I'm again going to put this into point slope form, and then I'll solve to put it into y-intercept. Or into slope-intercept, excuse me. So this will be y minus 1 equals 3/5 x minus 6. And I'll go ahead and do that for the other one. This will be y minus 1 equals negative 5/3 x minus 6. Looking back at this first one, I'll distribute the 3/5. So I get y minus 1 equals 3x over 5 minus 18/5. Adding 1, I will get y equals, I'm going to write this as 3/5 x with an x to the side. Now notice that the x there is level with the fraction bar, right? It cannot be below it, right? So do not write it as 3/5 and then x right there. Do not write it like that, because that looks like the x is in the denominator, and that is very different. That would make this a nonlinear equation, and that's just wrong. So do not write it like that. Now to add the 1 over, I'm going to just type this in my calculator. I guess this will be negative 18 plus 5, right? Yeah. So I would have negative 13 over 5. And for this other one, I will have y minus 1 equals negative 5/3 x plus 5/3 times 6. Well, the 6 and the 3 cancel to be a 2, so this will be 10. So y equals negative 5/3 x plus 11. All right, that is that. Make sure that we know that what are they? They're opposite reciprocals, or you could think of negative reciprocals. All right, good luck on the homework.